Hi everyone, thanks for watching my presentation today. I'm Kate Ringvall from the Curtin University Sustainability Policy Unit in Perth, Western Australia. I'm presenting to you today on a paper that we have been commissioned to share some of the research that we've been doing for UNCTAD, who are a research think tank in the UN. The UN's Conference on Trade and Economics has a number of projects underway, including the Sustainable Manufacturing and Environmental Pollution Program. And under this project, we have been tasked with undertaking this research. UNCTAD has defined the difference in distinction between plastic alternatives and substitutes. So bioplastics are seen as alternatives to plastics and because they are still functioning like a plastic with less harmful impacts. And substitutes to plastics are seen as something that act very differently, such as glass or metals. There are significant issues, however, with bioplastics that remain unsolved, including with those that are naturally derived biopolymers. Bioplastics that can only compost in industrial settings pose some management issues for those economies that are still lacking modern waste infrastructure. It's abundantly clear that in 2023 we have a problem with plastic. The most recent research tells us that plastic pollution has reached alarming levels, and the biggest problem with that is the threat to animal life that microplastics, human and animal life, that microplastics pose. Microplastics are a design flaw because as a society we've accepted that we can design products without any thought given to what will happen at the end of its life. And this short-sightedness has created a pollution problem that we are yet to get on top of. More recently, bioplastics have been getting popular with designers as the new better plastic. And based on their sources and biodegradability, we can classify plastic alternatives in a couple of ways. There's the fossil fuel, original fossil fuel-based biodegradable plastics. There's the naturally derived non-biodegradable plastics and the naturally derived biopolymers that are biodegradables. And while biopolymers are very good alternatives to petroleum-based plastics and are becoming more widely used, they still only represent 1% of the market. And fossil fuel-based plastics are exceeding production of something like 380 million metric tonnes. However, there are some serious obstacles to bioplastics being more widespread in usage. There continues to be a lack of mandatory standards in the sourcing of materials, their ultimate actual biodegradability, and the techniques required for compostability. In the main, such materials require industrial composting infrastructure, which the majority of emerging economies lack at scale. Plastics in packaging have absolutely revolutionised the growth and development of food exports, both domestically and internationally, and their impact can't be underemphasised. However, once again, because as a society we've tacitly approved the design of packaging without thought of its end of life, packaging is now a serious waste problem. So let's unpack a little the purpose of packaging. Packaging, especially for food exports, is important to keep food products hygienic and safe over long periods of time and distance. Now, though, it also plays an important part in preventing tampering, pollution, and ultimately damage. And recyclability is more recently becoming a necessary requirement of packaging. Now, good design in packaging takes into consideration everything from a user's range of dexterity, vision, strength, and cognitive abilities. And in 2023, we really expect our packaging to be much more than this and just that. Our expectations have expanded to include things like design for recovery, design for reuse, optimizing material efficiency, designed to reduce waste and pollution, completely eliminating hazardous materials, and preferably using recycled materials. The concept of the circular economy comes out of the earlier research around biomimicry, cradle-to-cradle design, and industrial symbiosis. And more recently, the work of the Ellen MacArthur Foundation have given us a much more mature definition, and they've clarified the 3 principles of a circular economy that we use in modern day. Number 1 is design out waste and pollution at every point. Number 2 is keep materials in use at their highest value for as long as possible. And number 3, regenerate the environment. Bioplastics have been suggested as the next wave of green packaging. And there have been some truly innovative discoveries, such as the work of Almeida et al., who have developed a biopolymer, bioplastic derived from the husk from cocoa production, and that appears to biodegrade well. It leads us to ask the question of whether it will be feasible to have plastic substitutes in a circular economy. I've developed this rudimentary table to try and explore what opportunities might exist for a range of materials to be used as substitutes for plastics in a circular economy in the food packaging sector. I'm sorry, it's very small, but if you read my paper, you will see it in better detail. Bioplastics obviously address the many issues that exist with the use of petroleum-based plastics, but they can't solve the numerous problems that are associated with mismanaged plastics. For the most part, the majority of bioplastics remain difficult to compost in a home or non-industrial settings. And this really poses some problems for emerging economies to adopt them. And this ultimately is at the heart of UNCTAD's push to make a distinction between a plastic alternative and a substitute for plastic. Emerging economies without the industrial infrastructure that's required to manage waste, in particular bioplastics, will still struggle with mismanaged waste clogging their waterways and washing up on their beaches. And what this table is really trying to do is really juxtapose the many opportunities that exist in different materials being substitutes for plastic in a circular economy. So what I've done here is really across the board, we're looking at everything from mushroom, seaweed, glass, pineapple leaves, hemp, bamboo, paper and cocoa. And using the 3 principles of the circular economy and the 6 principles of the early work of circularity and recyclability. And we're trying to address what are the options, what happens to that material at the end of its life? Can it be reused? Can it be used in a different way once its first use has changed or finished? Are there options for remanufacturing, etc., etc.? And this really describes some of the issues that we have. We really need to focus on design that's actually sustainable packaging, particularly with packaging materials, and really make sure that they're completely decoupled from fossil fuels and aren't competing for food resources. We need to remember that one product or organisation's waste output is another's material input to their production cycle, and that materials that are excess aren't waste. They simply lack an owner or a place to be useful. I want to acknowledge the help that we've had and the input that we've had in this research. We couldn't have done it without the help from UNCTAD, and we recognise and are grateful for the input from the Minderoo Foundation and my colleagues at Curtin University really thank you for watching our various recordings and reading our papers. Thank you very much.